All right, we're starting on page 583. We're going to be skipping quite a few pages because we're going to be jumping to 588 and then 590. So this is finishing up the third lesson in Module 4, Topic 2. Pretty much it's using the Pythagorean theorem, but on a coordinate plane. So let's start on our warm-up on 583. It says use the coordinate plane to answer each question. Number 1, how do you calculate the distance between the points A and B? So from here, we can just count. And when you count, you're counting the side lengths of the squares of the grid. So this is 1. Or think about how many steps you're taking. So this is the second step, third, fourth, fifth. This is the 6th step. So the distance is 6 units. But besides that, if we didn't have a grid, how could we figure this out? Notice the ordered pairs. We have -6, -2, and -6, -8. We could use, since this is a vertical line, we can use our vertical distance, which is the y value. Really what you're doing is you're subtracting. You're finding how far -2 is from -6. All right, so I was ignoring the negatives. You don't have to really focus on negatives here. For distance, we don't care about negatives. You would just subtract 2 from 8. Right, so -6 and -8, subtract 2 from 8. That gives us 6 units as well. So number 2, how do the negative coordinates affect the distance between points A and B? They don't. So they do not affect the distance. And that's because distance is always positive. Right? If you were to say like you walk 3 steps, you wouldn't say -3 steps because you're going in a specific direction. It's always going to be positive. Okay. We could go through these other problems, but I want you to just skip to 588. So I've crossed off getting started. This is all in activity 1. But I really want you to just practice starting on 588, so right here. That says, so activity 2, applying the Pythagorean theorem to determine distances. So like it's easy to determine a distance, like let's say from here to here. Like on the grid, that's 1 unit, even though I know that there's this technically 2 squares, but we're going by half. But that's 1 unit width. But it's a little bit harder to find when we have let's say, right, a diagonal distance. So when we're thinking about, right, how many units we're going, like if this is 1 unit, if it's diagonal and if I take that unit here and maybe, whoops, I'm gonna go back. And if I take that, maybe line it up here, maybe rotate it. I think maybe, like how many of these units, hold on, I keep grabbing the edge. How many of these units, right, would I have to like line up and like put side by side? Let me do that again. Right, so right now we're at 2 units, now 3 units. How many of these would it take for me to get to the other point? Okay, anyways, so for this, I'm gonna erase this. Right, how can we figure out that distance? How many units would that be? Right, so your first thing there is to connect it. So if we read number 1, it says calculate the distance between the 2 points shown. Connect the points with a line segment. So I'm gonna just draw a line from point A to point B. And then it says draw a right triangle with this line segment as the hypotenuse. So we're going to draw a vertical and a horizontal line. I'm going to draw like this and like this. So we have a right triangle formed by this right angle here. Okay, so we did that for number 1. Number 1b, it says determine the lengths of each leg of the right triangle, then use the Pythagorean theorem to determine the length of the hypotenuse. Round your answer to the nearest tenths place. So we're going to count here, and again, keep in mind, right, this is 1 unit, 2 units, 3 units, so on. So this technically is 1 and 2. So This is 2 units wide. And since, right, every 2 over here is the same thing. 1, 2. This will be 1, 2, 3, 4, and 5. So 5 units. So this is a 2 by 5 right triangle. We don't know what this hypotenuse is, so I'm going to put C. So let's use the Pythagorean theorem here. So rewriting the formula, a squared plus b squared equal to c squared, where we've been working with this. I'm going to plug in 2 squared plus 5 squared equal to c squared. Okay, so 2 squared, 2 times 2 is 4, 5 times 5 is 25, equal to c squared. And when we find the hypotenuse, we combine like terms, so 4 plus 25 is 29, equal to c squared. So that's not our final answer, right? It cannot be 29. That's why we take the square root of both sides. I've got to undo and get rid of that so that I only have c. This won't be a perfect square, so I want to put approximately equal to. Square root of 29, we're going to round to the nearest tens place, but we can plug this into our calculator. So square root of 29. Right, this is 5 point, that 3 is in the tens place, but if you look at the hundreds place, the 8, that 8 will tell the 3 to go up instead of stay, because it's above 5, so this is going to be, I found out here, 0.4. Since we don't have any units like centimeters or inches, this is just 5.4 units, and we're going to box that final answer. Okay, and pretty much the other part that I wanted to focus on the next page, on 589, we're just going through a series of problems with that. We have to just be careful with our axes and how many units we're going by. But let's go to start on number 2. So same thing, determine the distance between each points. Oh, sorry, I should have mentioned here. So our answer is 5.4. So we had said like this right here is 1 unit. So if I were to take this, right, and rotate it, it'd be 5.4 of these lines could just kind of stack. That would be 2, maybe 3, right? You keep going, right? 4, 5, and change, right? That many line segments for it to be the hypotenuse. Okay. All right, let's move on. Now we have the values here. We could use that. We could actually subtract, like, well, actually, let me draw this first. So this vertical change, this is, or are we going by ones? Yeah, this is going by ones, increments of 1, even though every 2 is shown. So this is 1, 2, 3, 4. You could find that it's 4 because if I take the y values, 8 minus 4 is 4. The width of this, 1, 2, 3, you could find that it's 3 because, I'll put in a different color, 6 minus 3 is 3, right? So that's what you're doing there. You're just really subtracting. Anyways, if we plug into the Pythagorean theorem, right, you may notice that this is a Pythagorean triple, right? We'll put c. 3 squared plus 4 squared is equal to c squared. We'll have 9 plus 16. 9 plus 16 is 25. And if we take the square root of both sides, that Pythagorean triple that we've talked in the past before is 5. Square root of 25 is 5. 5 units is our final answer. Okay, and I guess I could try to prove that here. Like, let's actually do what I was doing before. I take this and move it. Like, it should be 5 units. All right, that's 1. Let me copy another one. That's 2. I should really change the color here. That's 3, 4. Maybe I didn't quite line it up right, but it should be about like 5 units there. All right, so 5 units is our answer for the hypotenuse. Let's move on to the next one. So let's go and draw this. Oops. We'll draw a vertical line and horizontal line. Let's look at our units. So this looks like it's going by 1, 2, 1, 2. So it looks like it's going by increments of 1, so we can just skip count by 1. So this, I didn't quite draw my line right, but 1, 2, 3, 4, 5, 6, 7, 8. Right, so we're finding 8, that's our width of our x's. If you subtract -6 from 2, or the distance from -6 to +2 is 8 units. All right, let's go here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. And these two numbers are 12 units away. Okay. Let's say 8 is A, 12 is B, and our hypotenuse is C. And pretty much when we're finding the length of a diagonal line, that diagonal should always be C. So we're going to have A squared plus B squared is equal to C squared. We'll have 8 squared plus 12 squared equal to C squared. Or we're going to have 64 plus 144 equal to C squared. Let's do some scratch work off to the side, adding these two values. Or we're going to have 4 plus 4 is 8, 4 plus 6 is 10, carry the tens place to the hundreds place. 1 plus 1 is 2. So this is 208. So our final answer here is, if we take the square root of both sides, our final answer is the square root of 208. But that's not a perfect square, so let's use our calculator. Let's put 208 in the square root symbol. It says round to the nearest tens place, so 4.42. That 2 tells the 4 to stay because it's less than 5. The 2 is less than 5. So it should be 14.4. Like, what I mean by that, I shouldn't put that 0 there. It was 14.42. Right, think about this as $14.42. It's just saying like this is closest to which amount of like dimes, if we're thinking about this in terms of 10 cents. Is this closer to 40 cents or 50 cents? It's closer to 40 cents. So that's why we put, right, the 4 here for the 4 tenths or 40. All right. Okay. So final answer is 14 4/10 of a unit for C. Okay, and keep in mind, right, the hypotenuse has got to be bigger than each individual number, so it's bigger than 8, bigger than 12. So that's good. Okay, let's do one more, and I'll leave the last one for you do. Let's do this one here. Actually, I've been drawing vertical lines like that. I'm gonna draw it like this. I'm gonna go this way now. So normally, like for slope, we care about like rise and run in direction here. So remember, distance is not important. That it's negative. We just care, it's always going to be positive. So 1, 2, 3, 4, 5, 6, 7, 8 units vertical, 1, 2 units horizontal. So let's use those values and try to figure out C. So we're going to have 2 squared plus 8 squared equal to C squared. We'll have 2 squared, which is 4, 8 squared, which is 64. This is equal to C squared. Combine our like terms, right? 68 equal to C squared. We'll take the square root of both sides. Actually, it shouldn't be equal to, because that's not a perfect square. Right, like we know perfect squares, right? This square root of 64 is in between square root of square root of 60 is in between 64, which is 8, and square root of 81, which is 9. So square root of 64 is there, right? That's only 4 units away from here, but that is 13 units away from 81. So this is a number here that's a lot closer to 8 than 9. So it's going to be 8 point something. This could be like 8.2, 8.3. So let's just keep that in mind. Let's say 8.2. Okay. But let's plug this into our calculator to see how close we are to this. So we're saying 8.2. What's the square root of 68? So it's clear. 68 square roots. 6.24. That 4 would tell the 2 to stay. So we got it. We got it exactly. 8.2 units. So that's what C is. All right, go ahead and try this next one for Udo. But we're going to skip talk to talk and let's go to our assignment. Your assignment is everything. So number 1, looking at the image there, 2 and 3, and this is on page 591. Okay. All right, let's go and get started. Let me know if you have any questions.